This lesson is on factoring. In particular, we're going to look at factoring trinomials that have a leading coefficient of 1. That means our trinomials are going to look like the following: x squared plus bx plus c, where b and c are numbers, and our leading coefficient, meaning the coefficient of the x squared term, is 1. This is a simpler case than if the leading coefficient was a different number than 1. Recall, when we had two binomials multiplied together, this is in factored form, we could expand this into expanded form by using distribution. Notice that it is in factored form when your pluses and minuses are contained within brackets. It is in expanded form when everything is expanded and there are pluses and minuses that are loose out of brackets. That's just one quick way to see if it's in factored form or not. Okay, let's take a look at what happens when we distribute. We start with the first term and multiply by the first and the second of the second binomial. So we get x times x, x squared, and then we get minus 6x, and then we get plus 1x and negative 6, which is the last two terms multiplied together. And this can be further simplified by collecting the like terms. When you collect the like terms, you're adding up negative 6 and 1, and you'll notice if it's in this format, you're always going to be left with the two middle terms adding up. Negative 6 plus 1 is negative 5x, and we still have a minus 6. So here we have our expanded form. Now remember, factoring is going backwards. Factoring is taking it from expanded form back to factored form. So imagine you were only given x squared minus 5x minus 6. You'd have to somehow recreate what you've done with your expansion to get back to x plus 1 times x minus 6. To give you an idea, factored form is going to be useful when you're trying to solve equations that have squares in them in the future. But we'll look at that later. For now, let's practice trying to get it into factored form. So, let's just notice here that we've got all we have here that would be given to us is the negative 5 and the negative 6. We can see that the negative 6 was taken by multiplying 1 times negative 6. So the two terms here were multiplied to give us this last term. And we can see that we actually took 1 minus 6 to give us negative 5 for the middle term. So let's look at a general format and see if we can notice further what is happening. Here we have a general format, factored format, of two binomials multiplied together. So x plus a and x plus b. Notice that because we're factoring a trinomial that has coefficient 1, our first terms are always going to be the variable that is created in our first term. We have no other way of getting 1 x squared than to have x times x. So these are for sure there, but what we're not going to know is what to put in these positions for the factored form when we get our expanded form. So let's see what happens. We get x times x, x squared, x times b plus bx, a times x gives us plus ax, and our last term is a times b. So notice when you put it together, you get x squared plus, and I'm just going to combine these. You'll notice that bx plus ax is the same as adding a plus b. I'll just write it in alphabetical order so it looks nicer, but it doesn't matter what order you're adding it in, and plus a times b. So this is our expanded form, and this is basically what you're going to get, and you're going to be asked to find this factored form. So let's take note of how this a and b are found. Well, when you get your expanded form, you'll notice that the number by the x is the sum of your two numbers in your binomials, and the last term is the product. This can actually help us factor in the future. So let's take a look. Say you had x squared plus 5x minus 6. I think the signs are a little different than the previous example. So what's our middle term? Middle term is 5, positive 5, and our constant term is negative 6. Remember that the constant term was found by taking the product of our two numbers, and our middle term was taken from the sum of our two terms. So we're trying to get it into this format. We know that x times x will give us x squared for sure, but we're not sure what to put here, a and b. We're not sure what that is. However, we do know that those two numbers add up to 5 and multiply to negative 6. We can work with that. So my suggestion is always to start with the product first. Consider all the possibilities of multiplying to get this product. Afterwards, you can pick and choose those ones that sum to 5, because there are a lot of options of adding two numbers to 5, but there aren't as many options to multiply to a number. So how do we get 6 by multiplying two numbers? Either 1 times 6, or 2 times 3, or 3 times 2, and that goes back. So these are all the possibilities for numbers multiplying to 6. Hey, there's only 2. So now we want to figure out which one of them will sum to a positive 5. Our product is negative, meaning one of these numbers needs to be a negative. So when one of your numbers are negative and you're adding them together, you'll notice that you're always subtracting. If the product was positive, you'll notice that you're going to be adding. So take note here, if your product is positive, you're going to look at adding your two numbers to get your sum. If your product is negative, you're going to look at subtracting your two numbers to get your sum. So in this case, which of these pairs have a difference, or they subtract to a 5? Well, in this case we have to take 1 and 6. And now you can choose how to arrange your signs. How do we get a sum of positive 5 with one of them being negative? Well, we want more on the positive side, so the 6 should be positive and the 1 should be negative. 6 minus 1 is 5. You can check. Negative 1 times positive 6 gives us negative 6, and negative 1 plus 6 gives us 5. And that's how you find your numbers. Notice you can order them in any way. You could have the positive 6 and the negative 1 in the other places, and that would also be fine. Let's continue. So, what is the sum and what is the product? The coefficient of the leading term is 1, therefore our setup will be nice and easy with y times y giving us y squared. So this is the simple case. In the next lesson we will look at what if there is a number here, and it will be a little more complicated than this. So take note that only if it's 1 we can look directly at the sum and product and find our numbers right away. So the sum is the middle term, -4, and the product is the constant term, -21. Remember, the best way to find the two numbers that will come in and have a sum of -4 and product of -21 is to write out all the possibilities of your product. So let's start with 1 times, then 2 times, 3 times, and so on. 1 times 21, 2 times doesn't work. 3 times 7, 4 times, 5 times, 6 times, 7 times. Hey, that's it. So our product is negative, so we're looking for a difference, a subtraction of these two numbers to give us a 4. So, which of these differ by 4? And if none of them differ by 4, then you know that it doesn't work. And it is possible that you have nothing that you can factor it into, and we will look at that case a little later. In this case, 3 and 7 have a difference of 4. So here we're looking for a difference of 4. And so how can we put the signs on the 3 and the 7 so that we get a -4 when we add them up, sum them up? 3 take away 7 would give you -4, and 3 times -7 would give you -21. Sometimes you'll see the number right away, so just go for it. You don't have to take so much time on it if you see it right away. Plus 3 and -7, you can always double check. How can you check your work? Just distribute it out and see if it gives you the original question back again. Let's continue. Number 3 here, we're factoring something with p's and q's. You'll notice you have a little bit of a different structure here. You've got your square term, but then you've also got the q square term. So notice that your setup is going to look a little bit different, but still very similar because the leading coefficient is 1. So if you had p and p in the first position, you would get p squared for the first term. Great. Now you're going to need a number, which we will find using the sum and product. The sum going to be -6 and the product is 9. But to get this q squared, we're going to need a q term in the second position. So notice when you take first times first, you'll get p squared. The next ones, you'll get something times pq. Great. And then something times pq. Great. So the middle term will end up being a pq. And the last term will be a q squared term. So now let's just find these numbers that are going to work for us. So sum of -6, product of 9. Product could be possibly 1 times 9, 2 times no, 3 times 3, and that's all our possibilities. And since the product is positive, we're looking for a sum of 6. So which of these sum to 6? 3 and 3. They sum to a negative, so we want -3 minus 3. That gives us -6, and -3 times -3 gives us 9. So we have -3 and -3. Notice that this is actually the same bracket. It could be written as p minus 3q squared. A little later, you'll also learn about special factoring, and this is actually a pattern that you may be looking out for in the future. But for now, you can always fall back on this process to guide you. Let's look at the next example. The next example has a different leading coefficient. So, if you have a non-1 leading coefficient, you need to try to use the greatest common factor factoring method to factor it out. Because at this point, we only have the possibility of factoring something that has a leading coefficient of 1. So let's see if we can factor this leading coefficient out, and in this case it's just a -1. So we can take out a -1, and that basically changes all the signs inside. So you've got a squared plus a minus 42, because if you multiplied the negative in, you would get the original back again. That's the beauty of these questions. You can always check your work. You can write it out and then check it and see if it gives it back. If it doesn't, then something went wrong and you can try again. Alright, so you've factored out the -1. Great. Now we're only looking at the inside bracket and we're trying to factor it. This -1 is just hanging out. So we want this a squared plus a minus 42 to become 2 brackets multiplied together, and we're going to try to factor them. We know that a times a will give us a squared, our sum is a +1, and our product is a -42. Now we're going to look for all the possible ways to multiply to 42. 1 times 42, 2 times 21, 3 times 14, 4 times, let's see if 4 does not go in. 42 divided by 5 doesn't go in. 6 times 7, and then 7 is already there. So these are all the possibilities. Sometimes you'll get a really big number, and if you write out all the possibilities, it'll be a more direct way rather than trying to guess one that works. Okay, the product is negative. That tells us that we're looking for a difference of the sum, a difference of 1. So which of these have a difference of 1? Well, 6 and 7 have a difference of 1. And 7 minus 6 will give us a +1. -6 times 7 will give us -42. Great. So -6 and +7. You can check your work. Remember, you can only multiply out 2 at a time, so you could multiply these out, see if that equals that, then multiply the -1 in. So here we have our completely factored form. Notice that this was factored, but it was not factored completely. You had taken out the GCF, but you hadn't completely broken down this. So it's just like when we're prime factorizing, say you had 18, right? And you had 2 times 9. 2 times 9 is factored, but it's not factored completely because the 9 could still break down. So that's the same scenario here. You factored one factor out, but this can still break down. Sometimes it can't, and that would be if you couldn't find any sum and product that worked for it. In this case we did, and this is factored completely. Let's continue. Whoa. Well, this one definitely doesn't have a leading coefficient of 1. It also has a different order here going on. So we're always trying to put it back into our format of x squared plus bx plus c, because that's what we know how to factor. So always take out your GCF first. Always look for that before you even begin factoring. So is there a greatest common factor here? Well, I think all of these will divide by 3, so let's take a 3 out. And then also we have an x in every single one, so we can take that out. And also an extra y in every single one. So let's see what we're left with then. 3 times 8 gives us 24, and times the x is already there, and we need another y. So let's check that. 3xy times 8y gives us 24xy squared. Perfect. Next term is a positive, and we don't need a 3, we don't need an x, we need an extra y squared. And the next one is positive, and 48 divided by 3 is 16. And the x's are gone, and the y's are gone also. Great. So we took the greatest common factor out. Now, is this inside bracket, can that be written as our form that we know how to factor? Well, we just have to rewrite the order. Remember, this is why I was always suggesting in the past to write your polynomials with decreasing exponential order. Because when it's in order, then you can notice patterns that you have noticed before. Alright, so let's rewrite that. The positive 1y squared should go first. The y term, 8y term, should go in the middle, and the 16 is the constant term, so it should go at the end. So now we have a polynomial with leading coefficient 1. In fact, a trinomial with leading coefficient 1. Great. So this 3xy just keeps hanging out until the very end, and we're trying to factor this. What's our product and what's our sum? Our product is 16 and our sum is positive 8. All the ways to multiply to 16, 1 times 16, 2 times 8, 3 times, no, 4 times 4, and that's it. The product is positive, so we're looking for a sum of 8. Which one's sum to 8? 4 plus 4. Therefore, we have y and y, because y times y gives us y squared, and plus 4 and plus 4. Notice you could also write this as 3xy, and since it's the same bracket, it can be written back as a square. Let's continue. Here we have x squared plus x plus 1. So, what's the product and what's the sum? The product is 1 and the sum is 1. So we're looking for something times something to give us 1 and something plus something to give us 1 also. Alright, well the leading term should be x because x times x gives us x squared. And now we're looking for the following. What are all the ways of multiplying to 1? Just 1 times 1. That's the only option. Okay, our product is positive, so that means we need to add up those numbers somehow to get to 1. Can we add these up to give us 1? It's impossible. So we've looked at all the possibilities and there are none. So if you have something that doesn't have an option of being factored, that means it's already prime. Remember, prime factors are factors that do not break down further. So you can say prime. And that's it. That means that that is completely factored. Although if you had a greatest common factor on this, you could take that out and that would be considered factoring it. You just couldn't factor this component further. So this is actually non-factorable over the integers. So both of those answers would be fine. Notice if you say non-factorable, you need to mention over the integers because there might be some way of making this work potentially with some sort of decimals or partial numbers, but we're always trying to factor with integers at this point.